Right, continue where we left off. We were working on the network manager controller. Just had to eat some food. Following a tutorial on www.3dgep.com, networking-in-unity-3-5 /. Right now we're looking at the network spawn players. And it looks like we're opened up our server project at this point. Screenshot below, add the following code. Player info. This code finds the network player script global placeholder replaced located above and uses it to instantiate 3 units above. So initially drop down the plane, it's your body. The group is parameter 0 using groups to make sure the spawn player functions correctly. Add the following code. On awake, and then on player connected. Yeah, but where are you writing? Server main. Server main. Okay. We'll switch back to the clients and import. It starts talking about RPC functions. RPC functions are where you have to have your information go to the server, and then the server can broadcast it back out depending on what needs to happen. And in the programming engine, like in the game software development engine, like Torque3D, they have it so that you just have RPC calls in between server and client. So client asks a question, server responds, and server decides based on what kind of question the client asked, what kind of response it's going to give, and whether it's going to respond to the other clients that are in the game. And that's for your code. A lot of the first person code is handled in the engine side, C++. So you don't really ever touch it unless you're trying to specialize what it is you're doing. This allows the client to control who can listen, see, or do whatever. I don't know if I'd want that. Maybe server only is what I would ever use. RPC mode dot server. And the server will determine whether or not I need to send something back out. Okay, restrictions on RPCs. Firstly, the network communication required for RPCs is handled by a network view. It means that the script containing RPC functions must be attached to a game object that also has a network view component. This is why we added a network view to the game controller object in the project above. Now I know why. The game controller is a dummy placeholder, so we don't need to synchronize the state of the object. However, the script calling network instantiate, and thus making RPC calls underwater, is attached to the game controller. For this reason, it requires network view, but the state synchronization property can be set off and the observed property to none. Secondly, an RPC function can have as many parameters as you want, but each parameter must be of the following type. So you can only use float, string, network player, network view ID, vector3, or quaternion. When tuned into our client, we can easily understand the spawning madness. I wonder if there's polymorphism. Do you think if I created two functions and I made one for 2 parameters, one for 3 parameters, and I sent 3 parameters, and then sent 2 parameters. Which one would get called? And connects again and triggers a new instantiate and a buffer to instantiate into 2 cubes. Third. Okay. When the client connects the first time, its instantiate call is buffered. When the client disconnects, it triggers a new instantiate. It also gets the buffered instantiate into cube, etc. However, not all. On the client side, the client has to clean up its old cubes before connecting again. The server cannot do that for the client. It's just no longer connected. So to clean up the client side stuff, you got to have a function that's undisconnected from server. And then you got to destroy them. Interesting. Delete these old player cubes, clean up the server side. All right, let's see what this is doing. So players is a new hash table. Function spawn player. Players player is equal to go. Delete player. Players player remove RPCs go network view go. Network destroy go. Players remove player. This function. Wow, that's this is a little complicated. But let's start prototyping that. We're gonna have to do that sometime. Server player manager. I'm gonna just translate this from Java to C#. Table name player and players is new hash table. To turn it off. All right, so function. The function calls in C#. You just have to say void. Void. In case it's probably private void. Spawn player. I don't know why they don't capitalize their function names. And this is going to be a network player type. Call it P player. Parameter. Right. And then we will get their info. Info. Player. Unity3D. And C#. That's weird. Find objects of type player info. I don't see a player info. Did he create a player info earlier? Let's take a look here. Unity server, server main, client main, Server player manager, server main, client main. Let's put these restrictions in here too. I want those. Float string player network view ID vector 3 or quart. Oh yeah, there is a player info. And that was the just a regular class. That's set on the game controller. And it told it what type of prefab to use. I need to be able to change my network player, so it makes sense to do that, doesn't it? So I'll save this. Scripts testing, make a new C# script, call player info. And it will create a game object, a public game object, and player prefix. Save it. Game controller. Oh yeah. That's going to search on the object in question to find player info. How do I do it that way? I mean, what's the point of that? Oh, this is an attachment to an item in my spawn player. I can figure out that function that's server side should just be looking at the client defaults, whatever those are, and deciding what kind of client it's going to be. No, I don't need that. All right, let's go back to things for server. Scene manager. Scene manager. Let's go back to things for server. Figure out what kind of player to spawn. Looks like they're assigning a variable to the command network instantiate player prefab, but they don't do anything with it. It seems stupid, but maybe they're going to expand it so that there's maybe they're going to expand it later. So in our game, we're going to have more than one type of player. We'll have brown player, red player, create a new material in our materials folder, red, create a new material, we'll call it green, red change to red, green will change to green, probably a forced green, yeah, I like forced green. We'll change that to a deeper red, a little darker, there we go. Oops. There we go. Scene. And we'll slap on a green. That doesn't matter. Pair prefabs. Pull green pair back. Pair, brown pair, green pair. Perfect. Different materials, different looks. I just need to zero out their position. Right. So I want to spawn red, blue, or you know what? We're gonna make brown blue because apparently that's what I want. Create material, get blue, blue. blue, brown, green, red. But I'm going to do a green, blue, and a red probably most likely. I want a red, blue, or green. If one player. One player. Instantiate. So mark that instantiate. Red player prefab. For 3, that up scaled by 3 units. Since it's probably 1 or 0, it should scale up. And then the default rotation, quaternion identity, with 0, 0, 0 rotation. The blue player. Fifth. Green. The green player. I see the switch about halfway down, switch you back to the client project. I'm not really sure how it knows. I don't know what player owns that object. Huh. The client. Click disconnecting notice the cube on the server and the client will remain where they are, etc. That's right. In Dop, you have to do the @ symbol RPC, and then C#, you've got to do the open bracket RPC close bracket. There's a couple other things that we can put in here. Float int. So int float string, network player, network view ID, Victor 3, and Cartinian. So they forgot int. Whatever. Where's our RPC modes? Looking at the Unity documentation, searching for RPC and looking to see if I can find the network view RPC function where it defines all the different RPC modes. Object position, rotation, group. Add players. Jeez. Always makes me tired. Reading and reading and reading. Finding a lot of useless information, finding some useful information. Anyways, guys, if you have any questions, just post them, and I'll answer them as best I can. All right. Looks like our excuse me. So what's the difference between capital network view and lowercase network view? RPC mode didn't recognize all. In the Unity manual. looking at the network view reference. I'm going to read it. Network views are the gateway to creating network multiplayer games in Unity. They are simple to use, extremely powerful. For this reason, I recommend you understand the fundamental concepts. And networking before you experiment with network views. You can learn a lot by going to the network reference guide. I've already read that. All right, in order to use any networking, including state synchronization or remote procedure, your game object must have a network view attached. Yes, that's apparent. State synchronization. So transform, animation, rigid body, mono behavior, and that's it. Scripted mono behavior is called the function on serialized network view. Right. That means that if I put a network view on my game controller and that by a script file, in that script file I can put in void on serialized network view. I should be able to if stream is writing and if else it's serializing. Okay. No state synchronization will be used. This is the best option if you only want to send RPCs. So in other words, you add a network view to a game object, but this game object will never actually synchronize with the rest of the players. It's only going to be sending RPCs to the server and or receiving RPCs, I assume. The difference between the last state and the current state will be sent. Reliable data, no, okay. Observed. Component data will be sent across the network. View ID, scene ID, and then okay. When you add a network view, you must decide two things. What kind of data do you want the network view to send, and how do you want to send the data? The user property can contain a single component. This could be the transform, animation, rigid body, or a script. Whatever the user component is, data about it will be sent across the network. You can select a component from the drop-down, like dragging a component header directly to the variable. If you're not directly sending data, just using RPC calls, and you can turn off synchronization, no data directly sent. Nothing needs to be set as an observed property. RPC calls just need a single network view present, so you don't need to add a view specifically for RPC if the view is already present. All right, how to send data? You have two options. You can use state synchronization, which is reliable or unreliable. Reliable data compression is ordered. Packets always received note that it was sent. If observing a script, you must explicitly serialize data within the script. You do this within the onSerialized network view function. Sheesh. All right, the above function always writes an update from the stream when receiving the output. If you don't want everything is ready, that's in class. All right, onSerialized network view stream info. If the stream is writing, put a variable and then stream it. OnSerialized network view is called according to the send rate specified in network manager practice. By default, this is 15 times per second. If you want to use remote procedure calls, all you need to know all you need is a network view component present in the same game object in the script. Okay, so 15 times a second. Latency is determined at 80 milliseconds. So 1,000 would be 1 second. Divided by 15 would be 66. So essentially, it's just below latency threshold of 80 at 15 times a second. That should be plenty for what I'm doing. So that's good. All right. If you want to use the remote procedure calls in the script, all you need is a network view component present in the same game object the script is attached to. I wonder if I can make it slower though. Not slow. Well. Let's go again. So we could get 12.5, and it would still be close enough, huh? If you want to use remote procedure calls in your script, you need to use network view component. So 13. Why not? Let's change it. So um, edit, project settings, network, and debug level off. Send rate to 12, 13, 13. There we go. I don't even know if this project will work on the gear view. I haven't tested it yet. Maybe I should do that really quick. I set up everything else yesterday, right? Let's do a quick check. Unity 5, possible siege, assets, plugins, Android, assets, yep. And then build settings, Android, development build, their settings, resolution, icon, splash image, other settings, possible siege. Yeah, it looks good. All right. Okay. Why not? Let's do this thing. Public settings is good. So we'll build. Build will give us a pop-up asking us where we want to build. And we're going to build to test APK. We're going to name our test APK as well as siege. We're going to get our phone here. Go to settings. Applications, application manager. Find where we are, possible siege, and uninstall. Alright. Oh, I don't have my Android SDK root folder set up. Let's get that really quick. Loading, loading. I knew that I had set up the path in Unity 4.6.3, and I know I've got it set up in my Android Studio. Let's try to see which one loads faster. It looks like I chose the NV pack location. So that's what I'm going to choose here. Starting detecting current versions, yep, fetching libraries, building decks, creating asset package, creating AVK package. And there it is. Voila, test APK. Now run our command line. Again, I set up my path to my ADBs, so, or not to my ADBs, but my tools folder for my Android stuff. So no matter where I was, I could just type commands like ADB devices. I have no worry about whether I'm in a folder that has the ADB application running in it. I did that by changing my Windows system path file location. Okay. ADB install. Okay. Packaging. Delivering. Success. All right. So get my phone here. Sweet. No, it's even installed. Maybe I needed something else, huh? What did I name it? Go back out and go in. It's probably Oculus sample. I guess I forgot to change the name there. Let's get your Gear VR ready here. And then let's put it on. Yep, we've got our plane. Looks good. So that means Unity 5 is compiling for Gear VR. And I didn't see any problems. Let's make it really quick. Welcome home, Naomi. Yep, this is my daughter.
I'm starving. Help me.
All right, well, gotta stop again. Make food. I'll be back.